Good morning, everyone. Today is Monday, April 3rd. We are behind schedule. Okay, so I graded your homework, and several of you didn't submit your homework and didn't take the quiz. I haven't finished grading the quiz yet, so I will grade it today and tomorrow, and then we will talk about the quiz on Wednesday. Okay? When is the exam?
Friday.
Friday. So Friday, I will be here at 9:50. So, and then you can try to come early, then you can start early. Okay? So, and then you can take the exam up to 11 o'clock. So I have another class at 11 here, but if you need a little couple more minutes to finish your work, feel free. Okay? So when I'm teaching, when you finish, just turn in your exam. Okay? So you can stay a little bit longer. Questions? Then you email me and take the exam on Thursday. Okay. Yes. Can you take it on Thursday? Okay. Yes. On the makeup exam, you must let me know before Friday. So we only schedule makeup exam before the class exam date, not after. Okay? Yes, because if it's after the class exam day, everybody knows what's on the exam, so it's unfair to the student who take the exam on time. Okay, yeah. So Wednesday we have the review sessions at 8 p.m. So go to TED Live. Yeah, go to TED Live and join it. Okay. Have you started the practice exam? Okay. So, yeah, use red pen to check your work. And then on Wednesday, when we go over the practice exams, you can ask me questions. You can also ask me questions that you have on any problems. Okay. So maybe your homework or your quiz or like the practice problems that we didn't do in class that on your worksheets or any other problems. Okay. So review session is on Wednesday evening. Today we gonna continue we're behind schedule, right? So last time we talked about okay, we just talked about the steps of graphing rational functions, right? In chapter 3, we talked about how to graph polynomials. Okay, do you still remember the step when you draw a polynomial? You look at the what? You factor. So polynomial, okay, non-rational function. Okay, so polynomial, you factor completely. Right? Remember factor. Everybody say factor. So if the problem gives you the factor form, that's perfect. Don't multiply out. Is that clear, everybody? So sometimes students get lost. They don't remember the steps. So everybody, you still have the useful formula sheets for exam 2, right? So the second page, I list all the steps, how to solve polynomial inequalities, how to graph polynomials, and how to find roots, okay, for a polynomial of degree 3, okay? So we do those. Okay, so for polynomials, we factor. Because we don't have denominator, we only have numerator, so we factor it. And then we set each factor equal to 0 to find the x-intercept. Do you still remember that? And then we plug in x is 0 to find the y-intercept. And then we look at the leading coefficients. If the leading coefficient is positive, we start with the right upper corner. If the leading coefficient is negative, we start with the right lower corner. And then when you connect each points, you look at the multiplicity. If it's odd, what do we do? Cross. If it's even, balance. Exactly. So that is how we graph polynomials. Now, rational functions, not in exam 2, but in exam 3. Okay? So we have numerator and denominator. The first step, factor the numerator and the denominator. And then you want to find the x-intercept. So x-intercept means you set the numerator equal to 0 and solve for x. To find the y-intercept, we plug in x is 0 into the function, right? And then to find vertical asymptotes, you set the denominator equal to 0, you get some x values, right? And then you let x approaching to that number from the right. And then you see what happened with the y. Right, everybody? And you plug in the factor form. Do not plug in the multiply out form, okay? You plug in the factor form. And then what happens when x goes to a from the left? Okay? The y goes to infinity or minus infinity. And then step 4, horizontal asymptote. Horizontal asymptote. You look at the leading term of the numerator over the leading term of the denominator. Okay, so we don't want to factor it. Okay, we look at the original form. Okay, so and what happens when x goes to infinity? And if y goes to a number, a finite number, and then we have horizontal asymptote. Y equals to that number. Yes, everybody? And you also need to talk about what happens when x goes to minus infinity. Okay? And then finally, graph. Okay, so this is a longer process. Let's work on example 3. Okay. So, step 1, factor. Okay, what can we factor? The numerator. So 2x squared we can factor as 2x and x. And negative 4 we can factor as 2, 2 or 1, 4. But if you do 2, 2, that won't give you 7. Because 7 is an odd number and 2, 2 is even numbers. So you add 2 even numbers, you will get odd numbers. So it must be 1, 4. But which one, which 4? Let's put the 1 here and the 4 here, okay? And one of them is negative, right? So let's put plus and minus here and see if that works. If that doesn't work, we either change the sign or like switch to 1 and 4. So we multiply the outside. What do we get? Negative 8x. Multiply the inside, we get 1x. When you add them up, you get negative 7x. Do we have negative 7x? No, we have 7x. They just differ by a sign. So which means change the sign. Okay? If it just differ by a sign, that means change the sign. So this is minus, this is plus. Now when we multiply the outside, we get what? 8x. And multiply the inside, we get negative x. We add them up, we get 7x. Great. So this is the factorization. Oops. Okay, so here is the attendance sheet. And also, okay, this sheet, please sign your name that what time you want to meet me this week. I remember last week a lot of you signed the sheet, but only 2 students come to see me. So when you sign your name and the time, please also put a note on your cell phone so to remind yourself when do you want to meet me. Okay, everybody? So exam is on this Friday. I really want to meet you and make sure you're doing your work, and I want to see if you have questions. Okay? Yeah. All right. So keep going. Okay, denominator. What do we have? X and x. How do you factor negative 2? 1 and 2, but which one is negative? The 1 is negative. Very good. Then we multiply the outside. What do we get? 2x. Multiply the inside, we get negative x. Boom, add them together, we get x. So far, so good, everybody? Okay, so this is how we factor. That is the step 1, right? So step 1, we factor. Now step 2, find the x-intercept. Okay. We set the numerator equal to 0. Okay. Numerator is what? 2x minus 1 times x plus 4 equals 0. Right, everybody? Okay. So we get, that means the 2x minus 1 is 0, or the x plus 4 is 0. Right, everybody? Okay. And then, oh, by the way, if you didn't get the worksheets, you can print it out. It's on the website. Okay, so what's x? 1 over 2. Yeah, we move the 1 to the other side and divide it by 2. Or x equals, yeah, negative 4. Okay, they are x-intercepts. So x-intercepts are points. So you put x is 1/2, the y coordinate is 0, or x is negative 4, the y coordinate is 0. So these are the x-intercepts. Is that okay, everybody? Yeah, so when you get the x values, write down the x-intercepts. They are points. Okay, if you just give me an equation, that means it's vertical line. It's not a point. A point is an order pair. Parentheses, first number, comma, second number. Okay, everybody? So that is the x-intercept. And then next one, how about y-intercept? Y-intercept, plug in x is 0. So f of 0. Okay, let me ask you. So we have the original form, and we have the factor form. Which form do we plug in easier? The factor form or the original form? You sure?
I think it's easy.
Okay, so if you plug in the factor form, so you x is 0, then you still need to do the multiplication. But if you plug in the original form, boom, this is 0, this is 0, this is 0, this is 0. You will only look at the constant terms. Right? You don't need to do the multiplication. Right, everybody? So, of course, you can plug in both of them. If you don't make mistake, you'll get the same answer. Right? But looks like the original form is easier. Okay? So we plug in 0. So 2 times, can I just write negative 4? Or do you want me to write 2 times 0 squared plus 7 times 0 minus 4? Just negative 4, okay? Everybody okay? So yeah, when we plug in 0, we just get 0 plus 0 minus 4. Denominator, negative 2. Oh, what is negative 4 over negative 2? 2. We plug in 0. Yes, we plug in x is 0. That's why this is gone, this is gone. We only left with minus 4. And this is 0, this is 0. We only left with negative 2.
Will it always be the last number?
Yes, when you plug in zeros. You only get the constant terms. Because x is 0. Any term with an x is going to be 0.
Okay.
Yeah. Okay. So we keep going. Okay. This means the y-intercept is 0, 2. Okay, that is the y-intercept. Step 3. Find the vertical asymptotes. Okay, find the vertical asymptote. We set the denominator equals 0. Denominator, what's denominator? Yeah.
Right, equal to 0. So x minus 1 is 0 or x plus 2 is 0. Yeah, x is 1 or x is negative 2.
Okay? Many students just stop here. No, we have to compute the left limit. We need to let x goes to 1 from the right and from the left and see what happens to the y. Because we're not only finding the vertical asymptote, we also need to graph. So you need to figure out what's the behavior near that point. Okay? So we have x goes to 1. So if you have not enough space, because example 4 and the rest of this session, I will let you to do at home. Okay, so you can use the space of example 4 to continue with this example. Okay.
So let x approaches 1 from the right. Okay, x
Goes to 1 from the right. This corresponds to the factor x minus 1, right?
So we have x minus 1 go to 0 from the left or right? Huh? Left? Right, yes. They always match, right?
This is the plus and this is the plus. Okay.
How did you decide that?
Oh, you check both.
But usually we check the right hand side first. You would do x goes to 1 minus later. You do both. But usually we do the right hand side first.
Okay. All right. Let's keep going. Then the y will go to. Okay, let me ask you now.
When we plug in 1, do we plug in the original form or the factor form? Original or factor form? Factor form. Please plug in the factor form. If you plug in the original form, sometimes you cannot tell whether it's 0 plus. You can't tell the sign whether it's plus or minus.
So make sure you plug in the factor form. Okay. So now let's see.
Plug in the factor form. X is 1. Look at this. You get what? 2 times 1 minus 1.
Yes. And then next one, what do we have? 1 plus 4. And next one, x plus 1 becomes 0 plus x plus 2, 1 plus 2. Yes, everybody?
X minus 1 replaced by 0 plus. And then x plus 2 become 1 plus 2. Right, everybody? Yes. Okay, what happened to this number? What's this? Plus 1, right? This one is 5. Yeah, 2 minus 1 1.
1 times 5 over 0 plus times 3. Okay, what's the answer? Positive infinity.
Is that okay, everybody? Constant over 0 plus or 0 minus, you get either positive infinity or negative infinity. And it's positive or negative, you times the number of negative signs. Here, we don't have any negative sign, so positive infinity. Is that okay, everybody?
Yes.
Right?
Okay, and then x goes to 1 from the left. X minus 1 will go to 0 from the left. You know, everything almost stay the same, except you replace 0 plus by 0 minus. So what is the answer? Negative infinity. Good job.
I understand now.
Yeah, yes.
So from the right, it's positive 0. From the left, it's negative 0.
Yes. That's why we always do the right hand side first, because then the next step you just change the 0 plus to 0 minus.
Okay. And then how about x goes to negative 2 from the right?
So x goes to negative 2 corresponds to which factor? X plus 2, right? X plus 2.
So x plus 2 go to 0 plus. Now y goes to, look at the factor form. Okay.
We plug in the factor form. It's typical mistake is students plug in the original form. Sometimes the mistake will, because it's hard to tell how many negative, so that's why you send the answer it might be wrong by the time. Okay? So plug in the factor form. X is negative 2. 2 times negative 2
Minus 1, right? So 2 times negative 2 minus 1. Next one, negative 2 plus 4. And negative 2 minus 1. What happened with x plus 2? We plug in
0.
0 minus.
plus. Okay.
So look at this factor. So actually for each factor, we want to know whether it's positive or negative. We don't need to know exactly what the number is. We just need to know whether it's positive or negative. This number, positive or negative? Negative. This number, positive or negative?
Positive. So we have negative number times positive number over,
This is negative.
and then 0 plus. Okay, tell me what's the answer. Positive infinity. Because you have two negative, they cancel out. So you still have positive infinity. Okay, how about x goes to negative 2 from the left? How do you change? 0, negative. Y goes to, do you see what happened here? You have the same thing, but this becomes 0 minus, then you get negative infinity.
Okay? So once you look at we finished the right hand side and then the left side, it's gonna be change the sign. Okay? If your factor, the multiplicity is odd, then you know your answer is gonna change sign. If your factor, the multiplicity is even, then you expect they're the same. Okay?
So yeah, last time we did an example. Okay. So yes, if you forget about that, check your notes or the class recording. Okay, so therefore, vertical asymptote. So both of them are vertical asymptotes.
Because the y goes infinity or minus infinity. Okay, so both of them are vertical asymptotes.
Keep going. Step 4. Horizontal asymptote. Okay, horizontal asymptote, what do? We look at, we look at the leading terms of the numerator and denominator. So you let x goes to infinity, your y goes to, let me ask you,
You look at the original form or you look at the factor form? Original form.
okay, so you look at the original form. Okay, and you look at the leading term.
Okay, what's the leading term on your numerator?
2x squared, right? So 2x squared. How about the leading term of your denominator? X squared. Oh, what happened? X squared cancel. You get 2. And also, you also need to check as x goes to minus infinity, do you see your y will be the same thing? Yes.
Okay, because x squared cancels. It doesn't matter whether x is positive or x is negative. Right?
I see some faces.
Okay. This is horizontal asymptote. Do you remember? If the denominator is bigger, then you will get some x powers in the denominator. So when x goes to infinity, constant over infinity is 0. Okay? If your numerator and denominator same degree, then you only get a finite number. Okay, you get a number. Okay? Then the horizontal asymptote is y equals to that number. And in both cases, no matter x goes to infinity or x goes to minus infinity, your y will be approaching to the same number. Okay, so it's identical. But then if your numerator is bigger than the denominator, do you see your x's in the numerator? After you cancel some x, you still have x in the numerator. So when x goes to infinity, and you count how many negative signs. So no negative sign, then it goes to positive infinity. And then when x goes to minus infinity, x goes to minus infinity. Therefore, this goes to minus infinity. So when the numerator is bigger, then your result might be different. Okay? But if the denominator is bigger or they're the same size, your results will be the same for rational functions. Is that clear, everybody?
Okay. So even though the results are the same, you still need to check that. Because if you miss that step, you lose some points on the exam or quiz. Okay, so therefore, yeah, horizontal asymptote is y equals 2. Okay, now we're ready. Use all this information. Draw the graph. Okay, first of all,
X-intercept, 1/2, 0.
1/2 is like here. Okay, 1/2, 0, that's this point. -4, 0, this point.
So we plot the x-intercept. Is that okay, everybody? And then what's your y-intercept? 0, 2.
So this is 0 and 2, let's say 2 is here. Okay. All right. Now, vertical asymptotes. So they are 1 and -2. 1 is here. Okay, let's say this is here. And then you want to draw a dashed line to denote there is a vertical asymptotes. And then the other vertical asymptote is x equals -2. So -2 is like here, -2. And you also draw a dashed line to indicate we have a vertical asymptote. Okay, how about you guys take turns to answer my questions? Derika! Okay, now we're gonna start to plus some points, okay? X goes to 1. This is from the left or from the right? From the right, yes. So 1 is here. From the right is this side. Y goes to infinity, top or bottom? Top. So on the right, top. So we put a dot here. Is that okay, everybody? So we put a dot here. Okay, Quinton. How about here? X goes to 1 from the left, which is here. Then the Y goes to top or bottom? Bottom. So from the left, the bottom. So you put a point on the left and the bottom near to this line. Okay, everybody? So we put a point there. Okay. Diana. X goes to -2 from the left or right? Right. And so -2 is here from the right, this side. The Y goes to infinity, top or bottom? Top. So we put a point here. right? So we put a point here. Okay, Haley, how about this? Left or right? On the left, top or bottom? Bottom, yes. So we put a point here. Is that okay, everybody? Keep going. How about horizontal asymptotes? Let me use a blue line. Horizontal asymptote, y equals to 2. So y equals to 2. Okay? So usually when we approach the horizontal asymptotes, okay, you don't know whether we're approaching it from the top or the bottom. So usually you put a pair of points first. See, when x goes to minus infinity, and y goes to 2, so you put a pair of points here. And also when x goes to infinity, it's also approaching to this horizontal asymptotes. So you also put a pair of points here. Is that okay, everybody? Now let's graph. So by graphing, we actually means we want to connect all the points. Okay, let's see from the middle. We want to connect this point with this point. Yes. So and when you connect it, try to make it smooth. Okay, don't just draw a line like that. You know, vertical asymptote, we're approaching it. We never cross it or touch it. Is that okay, everybody? So don't just draw the line. So make the curve very smooth. And then we want to connect which point? This point, yeah. And then this point, right? So we connect them smoothly. Is that okay, everybody? Yeah, connect the points very smoothly. Okay, how about this side? We want to connect this point and this point. You tell me, which point makes more sense, the top one or the bottom one? The bottom one, yeah? So when you connect the points, you figure out which one make more sense. The bottom one make more sense. So we connect the bottom one, and then the top one, we don't use it. Is that okay, everybody? How about this side? Do you see we have this point? Okay, you tell me the top one make more sense or the bottom one make more sense? The top one, right? Then we can erase the bottom one. And then we connect them. So this is the graph of the rational functions. Okay? And it is 5 steps. Step 1, factor it. Step 2, find the x-intercepts and the y-intercepts. Step 3, find the vertical asymptotes. Step 4, find the horizontal asymptotes. And then use this information in step 5 to draw the graph. Okay? Plot the points, and then for the vertical asymptote, 4 directions, left or right, and then it's top or bottom. These are the 1, 2, 3, 4, 4 directions. You put the points very near to the line. Okay? And then for horizontal asymptote, you put a pair of points first. And then when you start to connect the points, you decide which point makes more sense. And then erase the other one. Is that okay, everybody? Okay, so this is how to graph rational functions. And I promise you, on the exam, I will only ask you the problem, the numerator and denominator, the degree up to 2. Okay, so you won't have very hard rational functions. Okay, it's at most like that. Okay. So, and then the rest of the problems, I will just let you to do at home. Okay, so this one and this one, all of these do at home. And because we're behind schedule, let's skip the slant asymptote. But you're interested to know more about slant asymptote, please see me. Okay. Okay, so this is 4.1 and 4.2. We're just right here. Then we need to talk about 2.7. I put it out. Let me grab it.
Distribute. Thank you.
Okay, 2.7. Inverse function. All right. Okay, so yes. So you see here,
We're going to talk about inverse function, and then we'll talk about exponential function and the logarithmic functions. They're actually inverse functions. That's why we want to talk about 2.7.
and for the remaining of the semester. So yeah, we are at week 12, right? And okay, and then the
Exam is right here. We only have like 4 or 5 weeks left. Okay, so it's not much time. So we talk about 2.7, and then we talk about chapter 5. Chapter 5 is about exponential functions and logarithmic functions. And then we talk about a solid system of equations and 2 variable equations and 3 variable equations, and also like maybe nonlinear equations.
and then yeah, that's it for the semester. Okay, so 2.7 inverse function. A function f is said to be 1 to 1. Okay, so 1 to 1. Oh, let me get the orange color. Or sometimes it's called injective. If f of a is not equal to f of b whenever a is not equal to b. Okay, so do you remember what is a function? So function is like a machine, right? Function is like a machine. You have some input, x, and then we have some output, y. Okay, so you can have several x mapped to the same y. That's possible. That's okay. But or you can have like one x mapped to one y. That is okay. But can you have one x mapped to multiple y? Can you do that? No.
Okay, this is not a function. So you can have like more to one or 1 to 1, but you cannot have 1 to more. Okay, and we also have the vertical line test. Like every vertical line pass through the graph at most once. Okay, so that is function. Now, 1 to 1 function says that you cannot have more to 1. You only have 1 to 1. Okay, so one input gives you one output.
So this is 1 to 1. Sometimes we use the notation 1 to 1. Yes. Okay. Example 1. Is the following function 1 to 1? Okay. Let's see. Look at this one. Can you see here the 5 mapped to the 5, but also the negative 5 mapped to 5?
So this is 2 to 1. It's not 1 to 1.
So this function is not 1 to 1. Okay. A virtual way to determine a function is 1 to 1 is using the horizontal line test. Okay, each horizontal line only intersects the graph at most one point. Okay, so this is the
horizontal line test. Each horizontal line must intersect the graph at most 1 point. See, if you have 2 points, that means those two inputs will map to the same output, so it's not 1 to 1. Is that okay, everybody? So at most 1 point means it could be 1 point, it could be 0 points. 0 point is okay, like here. You can intersect nothing. Okay, that's okay. But if you have intersection, or it must intersect 1 point. No, you cannot have 2 points or more than that.
Alright, so this is a horizontal line test. Let me also, we call you like vertical line test, because sometimes students get confused with them. So vertical line test is help us to check if a graph is a function. Okay, so every vertical line intersects the graph at most 1 point. Okay. So for example,
Is this a function? Yeah, because every vertical line only intersects 1.
okay, so this is a function. Okay, if you have a circle, is the circle a function? No, because if you use this vertical line, do you see you intersect 2 points? So that means
1 input gives you 2 outputs. So this is not a function.
Okay, so this is not a function. Or if you have something like that, ooh,
You intersected infinitely many. Of course it's not. Okay, everybody? Yes. So your vertical line test tell us whether a graph is a function. The horizontal line test tell us whether a function is 1 to 1. Okay? Are you ready?
okay, now check if the following functions are 1 to 1. Ikema, okay, look at the first one. Is it 1 to 1?
No.
Because you can pick any line here. You see, you intersect 2 points. So no, it's not 1 to 1.
How about this picture? Jackson, is this 1 to 1? Yes. Yes. Because every vertical line,
It just passed through at most 1 point. So yes.
okay, even. So how about the third one? Is it 1 to 1?
Yes. No. He kept saying, I know, it's not.
Yeah, right. If we take this line, it is at 3 points. So it's not 1 to 1.
Yes.
Yeah,
Yes, sure. Yes. Same thing. Yeah, so see, 3 points. So no, not 1 to 1. Okay. Any questions? So we look at the graph and then draw horizontal lines and see how many intersection points. Okay. Okay, when solving equations, we undo operation. So consider the function f of x equals 3x minus 2. Note that when we plug in 4, see, when you plug in 4, f of 4 is 3 times 4 minus 2. So that's 12 minus 2, so that's 10. Is that okay, everybody? So if we know the input is 4, then we know the output is 10. Okay, so we can go this direction. How about the opposite directions? Okay, what value? Okay, if we give the value, the outputs, can we find the inputs?
What? Say that again?
So if the problem says, okay, we know the output.
So if f of x is 12, find the x.
So this is the opposite direction. You give me the outputs. Now we want to find the inputs. So the process, okay, what do we do it? It involves like solving equations, right? You set
3x minus 2 equals to 12, and then you solve for x, right? We add 2 on both sides, we get what? 14, and then what's x? 14 over 3, okay?
So this direction is evaluate. You have the input and then you plug in, you get your output. Here, you know your outputs, then it involves like solving equations to find your inputs. Okay. But this process is like the reverse process. Okay? So F map 4 to 10. And then the inverse function, it maps the 10 to the 4. Okay? Or the inverse function, map the 12 to 14 over 3.
Okay, so it's like a reverse process. So the function f
Raised to the minus 1, this is called the inverse of f. Be careful, this does not mean reciprocal.
so f to the minus 1 is not the same as 1 over f. Be careful, it's not reciprocal. Okay, and so this is the input. Okay, so we also say domain, and then this is the output. We also say the range.
You see, for f, the domain is this part, and then the range is this part. But for f inverse, because you're mapping from here to here, but then for this function, this is going to be the input of this function, right? So therefore, this is the domain of f inverse, and then this is the range of f inverse.
Let me write it down. So this is domain for f. This is range for f. But if we look at the inverse function, this is the domain for the inverse function, and this is the range for the inverse function.
Can you see the domain and range kind of switch because you're doing the reverse process?
Okay, so main properties of the inverse function.
If f of a equals b, a is input, b is output, then the inverse function map the b to the a. You kind of switch a and b. Is that okay, everybody? So the domain of f inverse is the range of f. The range of f inverse is the domain of f. And for all x in the domain, we have, so this is composition function, right? We learned composition functions before. F composite with f inverse.
We just get the x back. So you have x, and then this is y. You have f, and then you take the f inverse.
You just get it back. Okay? Or f composite with f inverse, you also get it back. So the inverse function, they kind of cancel. Is that okay, everybody? You go around. Okay, you map here, and then you map here again, you get the same thing, right?
So therefore, it cancel. All right. Yeah. Let's continue on Wednesday. Okay. Have a nice day. Thank you.
So
Yes.
I just gotta remember which day I told you.
Right.
So I have class at 11. Is it okay if I'm at like 10:30?
Yeah, sure.
Go for like 30 minutes.
Sure.
Okay.
Sounds good. Bye. So Thursday, right? Not Tuesday.
Thursday.
Thursday. Okay.
Because I have an interview on Tuesday.
Okay. Have a nice day. Yes. Do you want to? Yeah. When are you gonna meet me? Okay. Is it today? Wednesday. Okay. So Chad, I also noticed that you missed it.
I think I turned it in late, but yeah, it was really late when I turned it in.
So you missed several quizzes.
Yeah.
Make sure you don't miss any more.
Yep.
And did you turn in your exam correction, exam wrapper, or the
I was still working on
homework?
that.
Okay.
Yeah.
This week, focus on your exam 2, your practice exam 2.
Yeah.
Okay? And then over the weekend, make
Yeah.
up all the missing work.
All right.
Bye.
Good morning.
Good morning.